Welcome to Study Loop.
In order to solve the given problem for part A, we use the formula that describes the frequency detected by an observer, that is f naught. Frequency detected by observer is equal to fs into v plus minus v naught divided by v minus plus vs, where v is equal to 340 meter per second, which is the speed of sound in air. V naught is equal to 0 because the observer is stationary. Vs is equal to 20 meters per second, which is the speed of the car. And Fs is equal to 250 Hertz, which is the frequency of the sound emitted by the car. We will use the minus sign in the denominator here, because the source, which is the car, is moving towards the observer. So substituting these values, we get f naught to be, and using a minus sign here in the denominator, we get 250 Hertz into 340 meter per second plus 0 divided by 340 minus 20, which gives us 265.6 Hertz. For part B of the problem, we are going to do the same thing as we did in part A. The only difference is that we will use the plus sign in the denominator because the source, which is the car, is moving away from the observer. So plugging the values and using the sign convention, we write f naught to be 250 Hertz times 340 plus 0 divided by 340 plus 20. And this gives us f naught to be 236.1. This is Hertz. For part C, again, we will use the equation that we wrote earlier, but this time we will replace V naught to be 20 meters per second, which is the speed of the observer, Vs to be 0 because the car is stationary. We plug the values in the relation, and we are going to use the plus sign in the denominator because the observer is moving towards the source, which is the car. So f naught is equal to 250 Hertz times 340 meter per second plus 20 meter per second divided by 340 plus 0. And this gives us 264.7 Hertz. For part D of the problem, we are going to do the same thing as we did in a part C. The difference is that we will use the minus sign in the numerator because the observer is moving away from the source, the car. So f naught is equal to 250 Hertz times 340 plus minus 20 meter per second divided by 340 meter per second plus 0, and this gives us 235.2 Hertz.